Today we're going to talk about velocity. And you're going to say, hey, what the heck? We just like 2 videos ago talked about this, all right? Didn't we? I mean, we talked about speed. We had this whole thing. It was like 11 minutes long or something. We talked about speed over and over and over again. And you'd be right if we were talking about terms in everyday life, which we're not, unfortunately. So how often have you heard somebody say, geez, man, how fast are you going in your car? Right? So how fast, we talked about in the last video, was about speed. You've probably never heard your friend say, gee, Billy, what is our current velocity? Because that would be weird, right? But also because velocity has kind of a technical sound to it. And I want you to think about that, because the fact that it has a technical sound implies that it gives more information. And so it is more technical. It is more useful in a physics sense. And so that's the way I want you to think about it. So I've come up with an experiment because I need to supplement my salary, and so I'm going to race insects for money, because that's what I do, right? And so I want to find out what's the fastest insect. So I'm going to try to gather together as many insects as I can, and I'm going to try to race them. And so I want to try to figure this out. So what I do here is I put a ladybug here. I think ladybugs are pretty fast. Actually, I really don't think they're fast, but that's what I drew, so that's okay. And then an ant. And so let's say which one? Who will win, right? The ladybug versus the ant. It's the classic brawl battle. So here we go. So I put them down on the starting position, right? So the starting line is right here, this 0 line right here. And initially I have them facing the same direction because I want them to race, right? So I want them to go towards the same place and see who goes farther in the same amount of time, right? So if I give them the same amount of time and one goes farther, that one must have more speed, right? Remember that from the last video. The ant, though, ooh, that ant always wanted to irritate me. Turns around before I can hit my start button on my stopwatch. So I get my stopwatch ready to go, I get ready to hit it, and the ant turns around. Oh, jeez, but I'm already in motion, so I go ahead and still hit it anyway. And I yell out, go, really, really loud, and it startles the bugs, right? They're freaking out. And so I hit it, I hit yell, go, same time, and they start moving, right? So I give them, let's say, 100 seconds. So 100 seconds later, so it's not quite 2 minutes. So it's a long time, whatever, you get the idea. But 100 seconds, and watch them crawl. And they're crawling away, still freaked out a little bit. That's my ant crawl motion, by the way. So 100 seconds, they get, I hit stop and I look up and the ladybug is already at the 7-meter mark right here. So I think, wow, that's pretty cool. So the ladybug made it 7 meters in 100 seconds. So how long 100 seconds? How far 7 meters? How fast? Well, I can do it, right? V equals D divided by T, right? You guys remember that? So in this case, V is equal to 7 meters over 100 seconds, or 0.07 meters per second. I'm not going to worry about sig figs. Don't worry about sig figs for this. We're just trying to talk our way through it. Okay, it's all good. So 0.07 meters per second. Is that fast? No, it's a bug. Let's be real, okay? So we'll just kind of deal with it. But I don't care if it's fast or not. For humans, I'm trying to figure out which is the fastest insect, right? And so let's compare it to what the ant did. Well, okay, so the ant already immediately was a little confused and turned itself around. So, but it started crawling, so that was good. That's positive. And it crawled and crawled and crawled and crawled and crawled. And at the end of 100 seconds, it ended up at the 7-meter mark on the other side, behind the starting line. So is that still okay? Sure, right. Could I say how long did it travel? Yep, 100 seconds. How far did it travel? 7 meters. And then how fast? Well, it looks like it's exactly the same speed. So even though the ant originally turned itself around, it had exactly the same time and exactly the same distance, and therefore exactly the same speed as the ladybug. Awesome. Neither one would be one that I would actually race for money, so just keep that in mind. Anyway, not that I do that, but I wouldn't choose these. There's got to be faster insects out there. But back to velocity. Is velocity different? Yes. So here's their 3 questions for speed. Okay, and there we got the same answer, so everything's fine. Velocity actually has 4 questions. So here's the 4 questions. Number 1, how long did it travel? Still 100 seconds. Awesome. Number 2, how far did it travel from the start? And that's important. How far did it travel from the start? You're going to see an example of this, why this is different in just a minute. The second part that's different is in what direction. So there's actually a follow-up question on number 2. In what direction? And you can see immediately that the ladybug went to the positive side or the right side. You could either say the east side if you wanted to. You could say that's north. It doesn't really matter. As long as it's that way, right, you're good to go. So I use positive because it's mathematical, and then you can do some math with it. So the ladybug went positive. The ants went negative directions. Those are just directions, right? And so how fast were they in a certain direction? So the ladybug, instead of being 0.07 meters per second, is actually positive because it's in the positive direction. It's moving positive. It's moving that way. And the ants, in this case, instead of being 0.07 meters per second, it's actually negative. So velocity here, speeds are the same. Velocities, you actually have a direction on there. We're going to find out velocities are vectors and speeds are scalars, and we're going to talk about those later on. So my quest for the fastest insect I can find continues. So I found this weird beetle. It's kind of box-shaped. And so I put the beetle on the starting line as well. And so I want to see how fast it is. I'm not going to race it because that seemed to confuse the ant. So I'm just going to go ahead and let the beetle be by itself. And I'm going to try to do the exact same thing. Give it 100 seconds and see what happens. So here's the question. I go ahead and set it up. I hit the start button. I let it go 100 seconds. I do my yell. And the beetle starts to crawl. And what I see is the beetle crawls this way, like so, and then gets confused or scared or something happens and turns around and comes back, like so. Okay, so at the end of 100 seconds, the beetle is actually on the 4-meter mark on the right-hand side. And so here's the question. What's the speed that the beetle had? Well, the speed would say, we ask these same 3 questions, right? 3 questions. How long? 100 seconds. Always. Same thing. No problems. Right? How far? How far did the beetle travel? So look at it here. So the beetle went 7 meters, turned around, and then went another 3 meters back, right? So 7, and then 8, 9, 10. So 10 meters total. So the speed here for the beetle is the distance it traveled, 10 meters, divided by the time it took, 100 seconds, or 0.10 meters per second. That's the speed, right? So immediately we know that the beetle is faster than the ant and the ladybug. Awesome. That's great. But it is also very confused. So something weird happened here. So maybe not so reliable. If I were to ask you, though, what the velocity of the bug is, in this case, the beetle is, we have to use those 4 questions again. So let's ask those questions. How long? 100 seconds. Easy. How far from the start? Okay. It doesn't say how far, period. It says how far from the start is it? And so here's the 0 line. Here's how far away it is. So this answer right here for this first part of number 2 is 4 meters. So even though we know the total distance was 10 meters, it's only 4 meters away from where it started, right? And so we have to answer that a different question because of the fact that it backtracked a little bit. We're only measuring away from the start. So that measure how far from the start is called the displacement. Right there, displacement. So displacement is symbolized with a delta x. It's how far it moved. It's how far its position changed. So its position was at 0, and now at the end of that time it's at 4. So what's the change in the position? Well, it went from 0 to 4, so now it's at 4. Doesn't matter what happened in between. It started at 0 and ended at 4. The displacement was 4 meters. So this displacement right here, which is that, there we go. And in what direction? I think you'd agree that's positive, right? It's on the positive side. So there we go. So what was the displacement? The displacement here for the beetle was positive 4 meters. Okay, and so we know how long, 100 seconds, sorry. We know what its displacement was. It was positive 4 meters, right? So it moved 4 meters away from the start in the positive direction. So how fast was it? We just divide those 2. So the velocity is actually the change in the displacement, or a change in position, like that, the displacement divided by the time. Like that. And so I took the positive 4 meters and the 100 seconds and figured it out. And so the velocity here is positive 4 divided by 100 gives me 0.04, that's positive, meters per second. So velocity is different because it has to take into account two things, right? The distance from the start, not the total distance traveled, and the direction in which it goes. And so between those two, it ends up being different. As you can see, the beetle, same motion, has a speed of 0.10 meters per second and a velocity of positive 0.04 meters per second. So it's a little different. Hopefully that makes sense. Thanks for watching.